So for special homework number 10, number 3, a sub k is the set soft bracket -1 minus 1 over k, comma, +1 plus 1 over k. So when k is 1, we just put a 1 in where the k is here and here. And that's -1 minus 1 over 1 for a grand total of -2, and 1 plus 1 over 1 for a grand total of +2, and it's this set. When k is 2, it's -1 minus 1 over 2, or -3/2, and +1 plus 1 over 2 for +3/2. So it's this set. We're not including the endpoints because these are soft brackets. What does a sub 3 turn out to be?
-4/3.
It is. It's -4/3. 2
And then positive.
4/3. So when we draw that, it's even smaller, right?
Mm.
Here's -3/2. But -4/3 is -3/3 minus a third more, so it's like right here. It's inside between -3/2 and -1. You see that?
Mm.
Because a third is smaller than a half. Like a third of the way to 2, right? So it's soft bracket, soft bracket. And then what's the last one? A4.
Oh, -5/4. And
Yes. And it's going to
uh,
be even inside there.
yeah.
The bigger you draw it, the better. But the point is, we're going in. So when we take the union, isn't the first one the union from I equals 1 to 4
Yeah.
of these sets?
Yes. They start from 1.
Right?
Mm.
So, right. So it's -2 to 2 union, -3/2 to +3/2 union, -4/3 to +4/3 union, -5/4 to +5/4. These are nested, right? They're nested inside each other. So what do we get when we take the union?
So -2 to 2.
Yeah. What about when we take the intersection? We're looking for the x's that are in all of these, because that's what intersection means. It's an and operator. We're looking for x that is in this set, and in this set, and in this set, and in -5/4 to +5/4.
So we don't have any.
What? I couldn't hear you.
So do we? I don't think we have 1 here, right?
You don't have one? Look at all
Mm.
these elements. Look at all these real numbers. There's an infinite number of real numbers in here. Aren't they in all of these sets?
Yeah, there are.
Aren't these in all these numbers? There's a gazillion of them. They're in all the sets, right? The ones that are in A4 are in all these other sets because each set is contained in the prior set. Oops, that went too far. But you get the drift, right?
Yeah.
So what's the answer? For the intersection?
It's gonna be like -3 over starting from -3 to over 2. No.
But -3/2 is not in A4 because -3/2 is over here, but -5/4 is closer to -1. See how it gets smaller and smaller? -3/2 is out here. See that? These get progressively, these sets get smaller and smaller and smaller. So any of the points, that are out here aren't going to be in this set. Like these points aren't in this set, so they're certainly not in these other two sets. -3/2, these points, not all of them are in here. Like these are missing. And between -4/3 and -5/4, these points are missing from the -5/4 to +5/4.
So
Have
it's
you
gonna be like -1 to +1.
No, it's not just integers. Do you understand that these sets are not just integers?
Yeah.
Okay.
S-
So do you agree that every point between -5/4 and +5/4 is also in -4/3 to +4/3? Do you agree that all of these x's are also in A3? You don't see that? I'm trying to figure out how to explain it to you with a picture usually does it. Is the picture big enough? Can you see what's going on in the picture?
Yeah.
What?
Yeah. No, I can't see it.
Well, you can see it,
I
or
can't.
you can, CAN. So let me pin this. All the elements in A4 are elements in A3, but A3's got some elements that aren't in A4. See, A3's got some elements, the ones between -4/3 and -5/4. It's got some elements that A4 doesn't have. So we pick the smallest set. That's the intersection. It's from -5/4 to +5/4. Does that make sense?
Yeah, it does.
Okay. What was the next question? Is it union from I equals 1 to infinity or what? What was the next part?
Yeah, union. Yeah,
From I equals union or intersection?
union.
All right, so if we take the union from I equals 1 to infinity of the A sub k, I guess these shouldn't be I's, I guess these should be K's. On the sheet, did they say K? They
Yeah,
should.
okay.
Yeah, we gotta have the same letters everywhere.
Mm.
K's, my bad. So does it matter how many more we add? Because each one is going to get smaller and smaller and smaller. They're going to get closer to being -1 to 1. Like, when k is 100,
Mhm.
the left bound is -1 minus 1 over 100. In other words, the left bound is 101 over 100, negative 101 over 100, which is really close to -1. And the right bound will be +1 plus 1 over 100. So the right bound will be 101 over 100. So it'll be even smaller. It'll be tucked in here, really close to -1. Does it help when we're building the union to have more and more of these? Does it improve the number of elements that are in there? Does it increase the number of elements that are in there? In the union?
Yeah, yes.
So what is that union? So, what is the union then? No matter how many more of these sets just get smaller and smaller, smaller. The next one would be 6/5, -6/5 to 6/5. The next one would be -7/6 to +7/6. But they keep getting smaller and smaller as they approach being -1 to 1. So the union is still the biggest set around.
That's gonna be negative.
So what is the biggest set of all of these? It contains all the other ones as subsets.
So -2, 2.
Exactly. The union is the set that contains any x that are in A1 or in A2 or in A3. So you get to include these flanges, these points in these flanges between -2 and -1. Even though not all these points are in all of these sets, they don't have to be in the union.
Okay.
Does that make sense? So what
Yeah.
about the intersection from k equals 1 to infinity? Now we have to pay attention. The sets have to be intersected. And that means we're intersecting with progressively smaller and smaller sets, that are tucked inside the prior sets, right? If we just keep doing that forever, what finally would be the only points that we could be sure are in all of these sets?
-1.
Mm-hmm. To 1. Because no matter if you try to take anything on the outside of -1 and 1, like -101 over 100 and +101 over 100, well, the next set wouldn't have some of those points because it would be, -102 over 101 to 102 over, so it would be missing some of the points that are in A100. A101 wouldn't have all those, and A102 would not have all of the points that A101 had. But all of these sets will have -1 to 1 in them. They have a little bit more on either side, but that amount shrinks as k gets bigger because 1 over k gets smaller and smaller as k gets bigger. So the only thing we're guaranteed in the infinite intersection is everything from -1 to 1. Does that make sense?
Yeah, that's
Good. Ollie, you're here. Do you have a question?
Hello.
Hi, Ollie.
Hi. Hello. Um, sorry, I don't have any questions for this.
It's Isaiah. Sorry, it's Isaiah, right?
Yeah.
Hey, Isaiah, did I send you an email?
Yes.
Okay, so we'll talk about that after office hours.
Yeah.
Anticott, you have another question? Did you want to see, like, was there a part B from this question that you needed to see?
Oh, I did that one. Yeah. So,
Can you speak in a
oh, you can
complete,
hear, you
can you
cannot hear
speak in a
me?
complete sentence so I know what you need?
Uh, so can we work like on number 5 from the other one too?
Sure.
So the
The unions and intersections of intervals?
mhm.
Sure. You can do part B of number 3 now, or you understand it enough that you can go back and try to do it?
Yeah, I'm gonna do it by myself. Try that.
Yeah, I mean, a picture really is going to help you. These
Okay.
pictures are critical, I think. Sure. Let's look at number 5. So we're going to find each set and use interval notation, right?
Mm,
And the universe is the reals.
yes.
Okay, here we go. So I tried to make the point that these aren't just integer sets by putting some decimals in here. So we're taking the union. First set goes from -3. Are we including the -3?
Yes. On this
Because
one.
of square bracket.
Mm,
Good. To 2.43. And we're going to union that with the set that starts at 1.24 and goes to 5.21 soft bracket. So again, draw a picture, from -3, -2, -1, 0, 1, 2, 3, 4, 5. Guess we can go to 6 because it goes to 5.21, right?
mhm.
So this goes all the way from -3 to 2.43. So that's like here, right?
Yeah.
Almost halfway to 3. So we're not in, so it doesn't include the right bound, but it includes the left bound. Can you see that okay?
Yeah.
And then the other set, we draw it just as carefully. Where does it start?
On 1.24.
1.24.
Yeah.
Do you know where 1.24 is approximately?
Between.
It's like a quarter of the way. We put a square bracket there, right?
Yeah.
And it goes to what?
5.2, 5.21.
5.21. Okay. So 5.2, 5.2 is about a fifth, right, of the way to 6. So it's like here. And we'll use a soft bracket. 5.21. So it's these elements.
So so we have to find the union, right? So
Yeah, so the first thing we're going to do is, yeah, we're going to find the union.
so it's between like 1 point, oh, -3.
So where are we going to start? What's our left bound?
1.24. Yeah.
This is a union. I think one of your issues is you don't know the difference between a union and an intersection. The union looks like the OR operator.
Also, everything in that.
Everything that's here or here.
Okay, -3.
-3, 2. We square bracket, right?
Yeah.
Because -3 is part of this set. So we're going to include -3. And how far do we go to the right?
5 to, yeah, 5 to,
5.21.
yeah.
Soft bracket. We're not including it.
Okay.
And now we can use the same picture to look for the intersection. The intersection is the overlap.
Oh, it's gonna be
It includes this endpoint because it's included here and it's in here. But it doesn't include this endpoint because it's, even though this endpoint 2.43 is in the bottom set, it's not part of the top set, see? So it's not in both. 2.43 is not in both sets because it's not in the top set. It's not part of this set. But 1.24 is in both sets because it is included in the bottom set. And it's right here, in the middle, it's inside the other set.
another 1.2.
So what is the intersection? Oh, this is B. Oh. So what is the left bound?
So 1.24.
And do we include it with a square bracket?
Yeah.
And what is the right bound?
So it's gonna be -3 because included.
The right bound?
Oh,
-3 is not part of this
oh yeah, 242. Yeah,
245 or whatever
yeah,
it was. 243. Is it 243?
yeah.
2.43. And do we include it?
No, because it's not.
Because it's not part of this
Yeah.
top set. Now we're going to do set subtraction for part C. We're going to subtract them. So we start with the elements in this set, the bigger set.
Mm.
So we start with all of these and we subtract away the elements that are in this set. So we subtract away these. So we're going to subtract away these that are in red, this overlap. We subtract those.
So we're gonna be left with the -3.
Mm-hmm. Because we're not subtracting away negative. So we're going to keep all of these, aren't we? So yeah, -3. Square bracket? Yes.
Yeah.
Ooh, thunder. I love thunder. And then what's our right bound going to be?
Gonna be 5.21.
Oh no, we have to subtract away all of
Oh,
the elements in this set, starting
so
with 1.24. We have to start subtracting from here on out. We take away all these. So we're really just taking away the red ones.
you're gonna go to the infinite.
So the question is, You see how we have to start subtracting at 1.24 because we have to subtract all of these?
Mm,
Does that make sense?
yeah.
So we go up to 1.24, but do we include 1.24?
No.
Because we have to take it away because it's part of the set we're taking away. So it goes like that. Does that make sense?
Yeah, it does.
Great. And now the last is, what is the last one? It's the complement of what?
Complex no -3 and 5.21.
So it's the complement of the union set, isn't it?
Yeah.
Is it 5.21 soft bracket? Did I put a soft bracket there or a square bracket?
Yeah.
So we want the complement of that set. So everything on the real line that's not between here and here. It's everything except these. So it's all these elements that are out here or out here. Does that make sense?
Yeah.
So how would we write those elements?
So negative infinity.
Yes, soft bracket always. Negative infinity to what?
No, positive infinity. Uh, yeah, we have to go that side too.
So what would be the right bound here? We have to stop here.
So -3.
And do we include the -3 in the complement?
Mm,
Is -3 in this? Is -3 an element of this set?
yes.
So we cannot include it because it's everything that's not in this set. So it's a soft bracket here. Then we jump over here and we pick up on the other side with these x's that are not in the set from -3 to 5.21. So we put a union,
Okay. Between.
and then we'll have these here. Now, do we include the 5.21? Do we put a square bracket or soft bracket here? Is 5.21 part of this set?
No.
So it's in the complement. So we include it in the complement. Does that make sense?
Yeah.
And then what's the right bound here?
Positive infinity.
Positive infinity. And it's always a soft bracket. Does that help?
It does.
That's good.
Absolutely.
Other questions? We can
No.
look at any of these that you want.
Hmm?
We can look at any of these that you want. Any of these homework problems. It's fine. Do you have any other ones you wanted to look at?
So we can do number 6.
Sure. Number 6 was a fun game.
Yeah.
So our universe is the set of elements from 1 to 12, right? The
Yeah.
integers from 1 to 12. So that's what we're dealing with. Our elements have to come from the universe because we're going to build A, B, and C, and they have to satisfy 4 properties. A and B are disjoint sets. Do you know what that means?
So they don't share anything.
They don't share anything. Good. They have an empty intersection. That means A intersect B has to be the empty set. Good.
Mm.
Now B is a proper subset of C. What does that mean?
So B is like the subset of C, but C is not is equal to B.
That's right. B is a subset of C, but C is not a subset of B. And that's, it's not equal to B. You could also say it's not a subset of B. And C's got to have something in it that B doesn't have. C's got to be, in some sense, strictly bigger than B. Does that make sense?
Yeah.
What's the next property?
Mm. So, A is there. So,
A intersects C,
yeah, at least one element.
has
At least one element.
at
Yeah.
least one element. So when we build them, we'll have to check to make sure that we have some overlap between A and C. We can draw a picture and make it easier for ourselves in a minute. We can draw like a little Venn diagram. And then finally, A cross B has 12 elements. So we know something about sizes of sets. If the cross product has 12 elements, then there's some different sizes for A and B that could work. A could have one element and B could have 12 elements, or A could have 2 elements and B could have 6 elements, or A could have 3 elements and B could have 4 elements, or A could have 4 elements and B could have 3 elements, or A could have 6 elements and B could have 2 elements. You see what I mean?
Yeah.
But we got to make sure that A and B are disjoint.
Yes.
So if we draw a picture to try to kind of help ourselves, A and B can't share any elements. So we could put A here and B over here. You can't share any elements, but I'm making B a little smaller because B's got to be a proper subset of C. So B's got to be completely contained in C. And A intersects C's got to have at least one element. So if this is C, there's got to be at least one element in there that C and A share. Does that make sense?
Yeah.
And then we just have to make sure that B and A have the right number of elements, that their cross product will have 12 elements. Does that make sense?
Mhm.
And then, whatever's in B will be part of C, but C is going to have, an element that's not in B, and it could be this element, or you could put another element in here if you wanted.
Yeah.
So, how many elements do you want B to have, and how many elements do you want A to have?
A for
You
A.
want A to have 4?
Yeah.
Okay, let's put 4 elements in A. And how many elements should B have?
3. Yeah.
Sure, 3 will work. And now that's just 7 elements, so we need to put the other 12 elements somewhere. You could put some more of them in C if you want,
Yeah.
but you could put more in C intersect A, except that would make A too big, right?
Yeah.
So do you want C to have any more elements? Or do you want this to be it for C?
Mm,
Does it matter? It doesn't matter. We're good right here. We could put the rest of the elements
yeah.
outside, the other, what this is 7 elements. We could put the other 5 elements out here, just out of our way. So now we have to just pick which elements, are going to be which. Like, what do you want to call this element? Which one of these do you want it to be?
So maybe 4,
Okay, this can be 4.
and A can be 1, 2, 4,
1, 2,
3.
4, and 3, right?
Yeah.
Great. What do you want these elements to be?
5, 6, 7.
Sure, that'll work. C and A and B are disjoint. And then these elements can be 8, 9, 10, 11, and 12. That'll work.
And C, we have to pick a number, right? Because we have
Oh, it's already got 4 elements. It's got 4 in it, and 5, and 6, and 7. So, because everything that's in B is in C.
Okay, yeah.
Does that make sense?
Yeah, that's no.
So when we, start to build our answer, we can let A be the set containing 1, 2, 3, and 4. B can be the set containing 5, 6, and 7. And C contains 4, 5, 6, and 7. We don't have to put, anything here.
Mm.
They're there. But we just check, are A and B disjoint? Well, their intersection is empty, so you'll be able to check that off,
Mhm.
as you verify. Is B a proper subset of C? Yes. Every element of B is also an element of C, but C is not equal to B. It has an extra element, namely this 4.
Yeah.
A intersects C has at least one element? Yes, A intersected with C has at least one element. It's got the 4. And then when you build A cross B, it'll have 12 ordered pairs because we have 4 choices for the first coordinate times 3 choices for the second coordinate. That'll give us 12 ordered pairs.
Yes.
So pictures really help us with these, all of these.
That's
Good.
Thank you.
You're very welcome. Was there anything else you wanted to look at?
No, that's it.
Oh, okay. Thank you for coming to office hours because I'm sure you won't be the only person that this helps.
Yeah.
Be able to
Thank you
post
so
these notes and people can look at this video when they
Yeah.
study for the test. Oh, today's my grandmother's birthday. God rest her soul.
Mhm.
She was a teacher. She taught first and second grade. Okay.
Okay, good night.
Good night. Thanks for playing.
We're gonna have office hours on Sunday, right?
Yes, we certainly are.
Okay, thank
All
you.
right.
Yeah. Have a
That
good
way
night.
we can look at the worksheet.
Okay.
All right. Good night. Ollie, do you have any math questions before I stop the recording?
No,
Did this
you can
help?
stop. It did.